We now talk about the properties of ammonia. See, ammonia is a colorless gas, pungent smell at a concentration above 5 ppm, parts per million. It is toxic. Okay. Its freezing point is 198.4 Kelvin, boiling point is 239.7. Is this clear? Now, it's highly soluble in water. Now, what happens is, all these three statements are now connected. What happens is, one of the major uses of ammonia is it is used as a refrigerant. Now, why is it used as a refrigerant? The main reason is that anhydrous ammonia, ammonia liquefies on cooling under pressure to give liquid ammonia. So what happens is, when you apply pressure to ammonia, it liquefies. Okay. And then when you release the pressure, what happens? It immediately evaporates. And its enthalpy of vaporization is 23.5. So it's endothermic. It requires that much energy to vaporize. Where does it draw the energy from? It draws the energy from the internal energy of the gas itself. It is clear. So the temperature of the gas falls down, and this cool gas is circulated around for maybe ice making plant or cold storage. So if an entrance exam question is asked that ammonia is used as refrigerant, the logical answer is because it has a very high enthalpy of vaporization. Its enthalpy of vaporization is endothermic, and that's quite high, 23.5 kilojoule. And that is the logic why it is used as refrigerant. So you can see I have explained over here that anhydrous ammonia is a clear liquid that boils at a temperature of minus 33. So when you pressurize it, it becomes a liquid. Okay, its boiling point is minus 33. So at room temperature, automatically when you release the pressure, it's going to evaporate. In refrigeration system, the liquid is stored in closed containers under pressure. When the pressure is released, the liquid evaporates rapidly. The heat required is drawn from the internal energy of the gas. The temperature of the gas falls down, and this cool gas can be circulated to manufacture ice, or it is used in cold storages. Is this point? We are now talking about chemical properties. Is this clear? So first is action of air. So simply if we burn ammonia in air or oxygen, what happens is it forms nitrogen gas plus water. Okay. And what happens over here is, the entrance exam question is that this burns with a yellow flame. So this is more important to us from the entrance exam point of view. But the same ammonia, when you react with oxygen in presence of platinum as catalyst, heat it forms nitric oxide plus H2O. And this is the basis of what we call, very important reaction. This is the basis of what we call as the Ostwald's method of preparation of nitric acid. Is this clear? Then the second reaction that we come across is reaction with chlorine or reaction with halogen. Let us start with chlorine. We have reaction with halogen. So when you're talking of reaction with halogen, we have got two things. With chlorine and with excess of chlorine. So ammonia reacts with chlorine, simply plain ammonia reacts with chlorine. Okay. And what does it give? It forms ammonium chloride, NH4Cl plus nitrogen. But with excess chlorine, so this is an important reaction from the point of view of any entrance exam, because moment they say chlorine, you have to be what you call very careful. Are they talking about chlorine or excess of chlorine? So with excess of chlorine, what happens is that it forms, so ammonia reacts with excess of chlorine, and what does it form? It forms NCl3, nitrogen trichloride plus HCl. So this different reaction. Is this clear? Then we look at with iodine. So with bromine, it simply forms ammonium bromide. Okay, just like this. So ammonia reacts with bromine to form ammonium bromide plus nitrogen gas. Okay. Now with iodine, what happens is, we'll write over here, we have space. With iodine, ammonia reacts with iodine to form Ni3 plus Hi. Now this Ni3 reacts with further ammonia and it forms the compound, okay, it forms the compound NH3Ni3, and this compound is called as nitrogen triiodide ammonia. Nitrogen triiodide ammonia, and this is a brown precipitate. So this could also be what you call a reaction which we should be concentrating on. Is this? See, reaction with active alkali metals. So the next one we have is reaction with alkali metals. See, interestingly, lithium, because of the anomalous behavior, when ammonia is passed over red hot lithium, lithium forms LiNH, of course, plus H2, which is imide. Whereas all other alkali metals like sodium, when it is passed over red hot, when ammonia is passed over red hot sodium, you get soda amide, NaNH2 plus H2. So soda amides, you should remember, especially soda amide. See, you must remember soda amide. If on soda amide a small amount of water is added, it immediately explodes. So when handling soda amide, you have to be very careful. So normal protocol is, how do we dispose of soda amide? We dissolve in isopropyl alcohol and then discard it. Is this point clear? Directly soda amide is never added to water in the sink. It can cause explosion. Is this point clear? So then we have the test for ammonia. So in your practicals, we always do the test for ammonium ion, and we have something called as Nessler's reagent. Nessler's reagent. Is this clear? So what is Nessler's reagent? It is K2HgI4. So we call this as potassium mercuric iodide. Slightly tricky to prepare potassium mercuric iodide. So what we do is, basically, we take potassium iodide and add mercuric iodide to that solution. So you get a pink precipitate, and then we add so much of KOH, strong KOH, 40%, such that the precipitate dissolves, and then this substance is formed. It's a clear solution, potassium mercuric iodide. Now this reacts with ammonia plus KOH. So I told you, you don't have to add separately KOH. That's already present in the Nessler's reagent. Is this clear? And now when you just react it, no heating, nothing, what happens? You get this substance called as HgI. Like, I need a little more space. We have HgIO HgNH2. So this is called as iodide of Milon's base. Plus किया है plus H2. And this is a brown precipitate. This is the brown precipitate. We continue with this and we talk now about uses of ammonia. So what are the uses? It is used in the making of fertilizer. Okay, second, refrigerant, just now I told you. Refrigerant, third, used in making of nitric acid, Ostwald's method, that is the next thing which I am talking about. So these are some of the We now talk about oxy acids of nitrogen. Nitrogen has three oxy acids. One is hyponitrous acid, H2N2O2, and this is the structure. This is clear. Then we have nitrous acid, HNO2, this is the structure. Nitric acid, what happens is the structure is like this. So you have the angle between O and O is 130. The bond length of NO bond here is 140. Angle here is 102 and 96 picometer. It is clear. So in some boards they expect you to know the structure. So it is in that itself is one question which they ask. It is clear. So actually you understand one thing. How are the questions basically? Questions are divided into factual, analytical, conceptual and description. So when you talk about the analytical questions, numericals and diagrams come under that category. Is this point clear? So laboratory method of preparation of nitric acid is by reacting chili saltpeter with concentrated sulfuric acid. So what happens? Chili saltpeter is sodium nitrate. Maybe in earlier one of the videos I must have said that chili saltpeter is potassium nitrate. Let me correct it. Chili saltpeter is sodium nitrate because Indian saltpeter is potassium nitrate, it is hygroscopic. Okay. So sodium nitrate is chili saltpeter. It reacts with H2SO4 and what does it form? It forms NaHSO4 sodium bisulfate and it gives you HNO3. Okay. So this is the simplest laboratory method of preparation of nitric acid. We now look at the commercial method, that is Ostwald's method. Commercial preparation. We come to commercial preparation of nitric acid. So when you're talking of commercial preparation of nitric acid, what happens is we take ammonia. This is called as the Ostwald's method. This is called as Ostwald's method. So what happens? We take ammonia, pass air or oxygen through this in presence of a catalyst. That is, we have a platinum rhodium catalyst. Okay. And the temperature maintained is around 590 Kelvin. So what happens is you get nitric oxide plus H2O. You all know that nitric oxide is what? It's an odd electron molecule and reactive. So this nitric oxide reacts with further oxygen to form nitrogen dioxide. So you can see over here both nitric oxide and nitrogen dioxide. So we have over here nitrogen dioxide is an odd electron molecule. Now this reacts with water. Nitrogen dioxide reacts with then water or is passed through water, and what do you get? You get HNO3. This HNO3 formed is about 68% concentration. Now this nitric acid is passed over okay, sulfuric acid, concentrated sulfuric acid, okay, a strong dehydrating agent, and you get HNO3 now, which has a concentration of 98%, and this is called as aqua fortis. So remember, this is for the entrance exam, that concentrated nitric acid 98% purity is called as aqua fortis.